Hello, this is Jian Li from KAIST. I will present today the research from two different institutes, one from KAIST and another from DIGIT. This is collaboration work. So what we'll talk about today is about the referred vibrotactile feedback for bare hand XR interaction. And our main idea is the event-based triggering. So our motivation is about the bare hand XL. So as all we know is the Excel is already here, but to make it more in real life, we need to use bare hand interaction because carrying controller whole day or wearing glove in whole day is not so practical. However, there's some limitation that for the bare hand, it can serve as a natural interaction and is good, but there's no tactile cues. So it mainly dominate for the visual feedback or audio feedback, but actually that can be a bit hard for some times. So that's why our research was initiated. We want to give tactile cues for bare hand XR interaction. So our approach is targeting the practical uses. So we decide to use smartwatches. As all we know, smartwatches already everywhere, and almost who love immersive headset, they already have smartwatches. So we targeted smartwatches to give a vibro tactile feedback. So that's the referred haptic feedback, the vibration at the distance, not the contact point. So usually we do interaction with the fingertip, but we can give a vibration on the wrist or opposite wrist or even in the pants pocket, which can be same as a smartphone in the pocket. So our system architecture is constructed to the three different parts. One is headset, as all we know is it is for the XL rendering and interaction for hand tracking and everything, and smartwatch for the Pixel Watch for the vibration. So headset and smartwatch is communicated through UDP socket, so that will be a real time, and we tested the latency, and it was less than 10 milliseconds. And also to do is we don't know how to make a feedback, design a feedback. So we made an online authoring tool which is connected through WebSocket to the headset and the web browser to enable participants to design their own feedback for pressing a knob and grabbing. So we choose three main tasks for implement and testing the vibro feedback. So one is the button press, and the second is knob rotation, and third is the object grabbing. So why we choose these three is one is the button press is most discreet and clear for the start and end, and actually is quite most popular one, so we choose that one. And the next, the knob rotation we use for testing the continuous and precise control. Like uh, for press, we only have unpress or press, but for the knob, we have to utilize for rotate how much and adjust or something. And more giving more freedom, we put the object grabbing. It is more continuous. And we define five different event states on hover, on select, on value change, on deselect, and on hover to show what it means for each task. First, for the push, it is the contact point starting, and rotate is touch started, one finger touched it, and grab is about one finger touching. So it is on hover, and then on interaction means it start pushing and it begin rotation with the two finger and it begin grab with the two finger. And then uh, Next step is about the reaching the max position and when the value changed and when start moving. And then for decel is the on hover is releasing back after max position back to the releasing and the end rotation, one finger leave, and end grabbing, one finger leave. And at the end is about end push, touch end, and touch end. So this is a 5 step for 3 different tasks. And authoring tool looks like this. It has GUI and actually instructor uses. Anyway, we can select multiple vibration tactile feedback too. However, we only focus on the square signal because following previous research, actually a square can convey many different patterns and uh, to ease design, we didn't target the different like ramp up and ramp down or other textile feedback. So we focus on the pattern lengths and strengths and the repetition. So for the study one, uh, our purpose was designing the Viver tactile feedback and test, investigate is there any patterns about that. So we done the study with the 10 participants and all of them was experienced AR/VR users. Uh, we recruit 10 experienced users because we don't want to uh, interrupt the study by their unfluency on the bare hand interaction. So that's why we targeted the experienced user and they could solely focus on the feedback design. So we tested 4 different placement, index finger and dominant wrist and opposite wrist in the pocket. And for the index finger, we use same smartwatches and we tighten with the strap. And the method we used was the participatory design. So user create their own haptic patterns by uh, thinking aloud. Like there was one instructor listening about the participants, and they was talking about uh, give more strength or less shorter or longer, and then our instructor applied the design. So our research question was 3. What was how should rival type patterns adapt across the location and events, and can refer feedback improve user experience, and which body location are most effective? So these are raw results from all possible four different body parts, and this is design. We can simply see some patterns like for Nove they use single, and actually there was not much repetitive patterns. So we run the linear mixed model comparison for strength and duration, and we put the model building approach by adding uh, one more fixed parameters. So in finally, we got the placement, interaction type, and event was affecting the strengths. And also for the duration, event, and interaction type and placement was giving some effect. So key finding from study one is a short discrete pulse was preferred and placement dependent intensity was needed and state change over contact. So they put more stronger signal on the unselect than on the hover. And shorter duration for continuous means uh, like no, when they need more touch, they was needed. And wrist preferred overall. And the second study was looking on the effect of the task. So there was a 16 new participant and there was 4 conditions. And the study was counterbalanced by Latin square and we got NASA TLX preference and interview 2. So below table shows the parameters what we use for each task and it was resulted by study 1. And study 2 results shows there was no significant difference on all performance measures, including completion time, success rate, and NASA TLX. However, we found significant difference on both wrist was better than baseline or pocket. So actually, we did more in-depth qualitative results with the thematic analysis, and actually 94% found haptic was helpful, and why? And 69% said knob rotation benefit the most, and also said pocket was least helpful. But however, why wrist works? Easy to understand the state interaction, can interact without looking at it, and also better awareness on my input. Why pocket fails, cannot trust it. Sometimes I could not feel. Feels like notification, so it was quite similar to the phone, so there was inconsistent. So we found three more findings from our study 1 and 2. So proximity doesn't mean better. Actually, index finger was more classic but least preferred. And also for the dominant wrist and opposite wrist, there was two different opinions. Some prefer dominant wrist as an intuitive, but some prefer opposite wrist as a less restricting. However, for both, consistency was matters. The key thing is why they don't like pocket or index finger is they feels like they don't give some consistent feedback. And also, there was everyone prefers this to implement it. However, there was no much measurable speed or accuracy gains. So we could find four different design implication. One, when build the referred vibratactile feedback, there should be short discrete pulse for state change and prioritize consistency over proximity and support user customization and target complex task. Not simple task is not so enough. Mhm. So conclusion. So we have some future work. We can explore more different waveform for the haptics and also try by manual or mobile scenario or with the other sensors. And thank you for listening. And this was Kaist from this was Julian Lee from Kaist. Thank you.